All right, good morning. Welcome back. I hope you guys are doing well, staying safe, and ready to roll for the best class of the day. All right, here we go. We do have a couple people still in the classroom, so I will be doing a little bit mix of classroom interaction. I'll be going from obviously the screen to teaching the screen, but I will be dealing with or helping the students in class as well. Just a little heads up. I'm looking for a few people today. I'm looking for Alex if you're here. I'm looking for Santino. Thanks, Frank, for letting me know. Hopefully he goes for. Okay. Looking for Santino, looking for Joey, looking for Tristan, and looking for Bellman as well. So if you're here, please let me know. So Bellman, Tristan, Joey, and Santino and Alex. If you're here, please let me know. All right, hopefully a few more people pop into class and make it a little bit more difficult for me as we move on. We'll see what happens. All right, so here we go. Let's check out first things first. Sticking with that routine. Hey, Bellman, there's one of them. Bellman, welcome back. Please try to get here a few minutes earlier. I appreciate it if you can. Let's check out the COVID report for today. So I was reading through the news, checking out the news this morning, and noticed that one of the vaccines, there's still 3 vaccines that are given out in America. We have Pfizer, Moderna, and Johnson & Johnson. The Pfizer is a 2-shot vaccine. Moderna's 2 shots. And the Johnson & Johnson's a 1 vaccine, and you're good to go. The thing is, the Johnson & Johnson, at this point, they're like pausing the administration. They're pausing the vaccines on this until a later date because they're having, I guess, a couple cases where it didn't work out as what they thought it was. So if you or mom, dad, grandma, whoever's at home signed up for a Johnson & Johnson vaccine because it was 1 dose, just heads up, it might not be given out as frequently or as you expected it. Hey, Santino, hopefully everything's going okay over there. Frank filled me in, so hopefully everything's all right. All right. So that vaccine might not be given out right now until they have more testing or more stuff they might want to analyze. Let's check out the total number of cases. Let's check out the COVID report for Oneida County as of today. We have 398 active cases, so we're getting closer to 400 again for active cases of COVID. We have 20,048 resolved cases of COVID. Good. But with that, there's 413 people that passed away from COVID complications. Number of hospital people in the hospital, 20 people in the hospital, 4 people in ICU. If you remember back to January, there was like 44 people in ICU. We'll take 4. If you check out the number of vaccines, that is increasing quickly. Awesome. And let's just check out the number of cases from yesterday or the day before. There's that peak, curve. Nothing too crazy from a distance. Let's just check out the number of COVID cases. 38. So on the 11th, last day's data, we have 38 cases of COVID. Day before that was a good number of 22. Day before that, the 9th, there's 50. Day before that's 48. So yeah, we're kind of inconsistent. Cannot really predict a trend. I would guess that this would be from the holiday of Easter when people got together. This high peak here might be just the effects of Easter celebrations. But that would be my interpretation on that. Nothing too much to really get too worried about. But do know that COVID's definitely still out there, still in the county. Protect yourself, protect your loved ones, mask up, social distance, do all that stuff to protect yourselves. COVID report for today. Let's figure out what's going on for the best class of the day. So welcome back. Here we go. The quote of the week comes from J.P. Morgan. The first step towards getting somewhere is to decide you're not going to stay where you are. If you want to go somewhere in life, you want to make something of your life, realize that you want your life to be better. Set some goals. Make a checklist of what you want to accomplish in a certain time frame. Go out there and do it. So again, the first step towards getting somewhere is to decide you're not going to stay where you are. A lot of you guys are sophomores, some juniors, some seniors in this class. You should start thinking about where you want to go, what you want to do with your life. Do you want to go right to work after high school? Where do you want to work? What do you want to do? Do you want to go to college? Do you want to go to 2-year school? Do you want to go to a 4-year school after high school? Start thinking about, what do you want to major in? What do you want to study in? What do you want to work in the field when you get older? These are things you should definitely start thinking about right now. So think about a school. Think about a program that would fit you. It's not a bad idea to start exploring maybe a college visit. Go to schools and analyze it. Figure out what the college feels like when you're on campus there. This is a good time to do it. Springtime, your sophomore, junior year, this is a good time to go check out MVCC's open house, Herkimer's open house, maybe Utica College's open house. See if it's a good fit for you. All right, moving on forward. Today's Tuesday, April 13th, 2021. Today's a day 2. We're continuing on with unit number 8, which is oxidation and reduction. We're picking up on topic 3, which is half reactions. We'll start off with a warm-up activity on redox reactions for 1321. We'll go through some guided notes, examples. We'll go through some Google Forms examples on topic 3. And then if we have time, we'll go through and give you time to work on the exit pass. Again, what am I grading in class? I'm grading exit passes, notes, benchmarks. That's it. That's what I'm grading for the course. Hasn't changed throughout the entire year. Next topic will be topic 4, which is voltaic cells, where we'll figure out what a battery is. Remember, like almost a month ago, I started off and I zoomed in on a battery and said, how does that work? We're getting there. It's the change, the flow, the losing electrons, the gaining electrons, all that stuff that is leading to topic 4 of a battery. We'll get there. I have a reference table below. We'll also sneak in a video here for today's class. So starting up, please go to the warm-up, scroll above. Scroll above, please go to the warm-up for 1321. Awesome, no one did it yet. So you may want to use your notes for this warm-up. You may not want to. It's up to you. You definitely want a reference table as we go through this. So please open up a reference table. And I will also open up my guided notes. So here we go. Use your guided notes. Please go through the warm-up. It should be a lot of review from topic 1, topic 2, questions. So I will give you 10 minutes to work on this right now. I'm going to ask that you please join your breakout room. Please attempt these questions. At 12:03, I'll break you out of the breakout rooms and we will go over these questions. So again, please work on warm-up for 1321. Please use your notes if you need to. At 12:03, we will go over the questions. If you have questions, please ask for help. Please join your breakout rooms. Please complete the assessment. Now, Frank, please join the breakout room. Ryan, please join the breakout room. Please attempt these questions. There's like 8 questions, 9 questions there. Please work on them. Thank you. Hey, Joey, we are working on the, hey, Joe, we are working on the warm-up for today. I'm gonna give you guys like 5 more minutes and then we'll come back together, okay? Please work on the warm-up. I'll put you in the breakout room and we'll come back together. Please join the breakout room. Please work on the warm-up. Thank you. Hey, Alex, good morning. Please try to get here a little earlier. We're working on the warm-up, and the warm-up is going to be on today's date. I'll give you guys a couple more minutes, and you're not going to have enough time to do it, but I'm going to ask that you join a breakout room. Please complete it. Try your best. I'll go over it soon.
All right.
Thank you. I'm sorry, guys. I tried my best. Oh. Yeah. Nobody really talked to me much on the computer. I try to get you guys to talk to me. Kai did a little bit. You talked to me a little bit. All right, another 30 seconds and we'll go through these questions. We'll try them out. Hopefully you had success with these questions. Oh, there goes my mask a little uneven again. All right, we're all back. Hopefully you went through those questions. Hopefully you had a chance to do them. Maybe you wanted to use your guided notes. Maybe you didn't. It's up to you. All right, here we go. Review questions from topic 1, topic 2. Question 1 says, which particles are gained or lost during a chemical reaction? Or a redox reaction, I'm sorry. I would have thought about Leo, the lion, says, grr. You should know this phrase by now. I've probably said it 100 times throughout the year. Leo, loss of electrons, oxidation. The gain of electrons is reduction. What's it referring to? It's referring to electrons. One, the best answer is definitely going to be choice A, electrons. Electrons are lost, electrons are gained in a chemical reaction, redox reaction. One is A. Next, number 2, oxidation reduction reaction involves, Leo says grr. Leo, loss of electrons. Grr, gain of electrons is reduction. It's got to be transferring of electrons. It did not talk about protons. It talked about electrons, transferring of electrons. You're not sharing them, you're transferring electrons. You're losing them, you're gaining them. If you're walking down Oneida Street and someone loses $100, they lost it, someone's going to gain that $100. So you're going to gain it, lose it, transfer of electrons there. 2 is best answer is going to be choice C. Number 3, which balance equation represents a redox reaction? Please put your answer in the chat for number 3. What's the best answer for number 3? Thanks, Tintin. Thanks, Zin. Faith, thank you. We're 3 for 3 so far. 4 for 4. Thanks, Chris Cross. 5 for 5. 24 people online, and we're 6 for 6 now. 6 responses. In case you're lost with this question, you forgot to do this question, I would encourage you to check out topic 2 of your notes. Look at topic 2 and you can say, oh, there's a portion there for redox reactions. It wants to know which one's a redox reaction. Oh, recognizing a redox reaction right there in the pink. Redox reaction says if an uncombined element appears on one side of the equation and is in a compound on the other, the reaction must be a redox reaction. That will help you out a lot. Or you could go through, you could assign the oxidation numbers for every element within the compound. A couple different ways you could do it. I would look for an element by itself on one side and then in a compound on the other. By itself, in a compound. We know what a compound is. By itself, in a compound. That is the best answer. Choice A. Everything else is going to be compound, compound, compound. Oxidation numbers would not change. Compound, 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 compound. Oxidation numbers did not change. You could assign the oxidation numbers if you needed to. Compound, 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 compound. Only once an element on one side is going to be choice A. Best answer for number 3 would be choice A. Let's rewind for a second. What kind of reaction is choice B? Is it going to be Let's see. Is it going to be synthesis? Is it going to be single replacement, decomposition, substitution, or double replacement? What kind of reactions choice B? Yeah, thank you. Thanks, Jumila. Thanks, Joe. Choice B, even though it's two compounds making a bigger compound, it is still going to be a single replacement. Definitely a single replacement. What kind of reactions? Choice C. Check out choice C. What kind of reaction is that going to be? Is it going to be synthesis, single replacement, decomposition, substitution, or double replacement? Choice C, what is it? What kind of reaction is that one? $25 you guys on. Not one person knows that one, eh? I know somebody does. Ah, there we go. There's one response. Thank you. One good one. Thank you. I knew you guys knew it. Just don't want to interact today. All right. So yeah, that's gonna be a double replacement reaction. How do we get that? Thanks, Faith. Yes. It's gonna be a compound plus another compound yields a new compound plus another new formed compound. That is definitely gonna be a double replacement. Double replacement reaction. How about choice D? What kind of reactions choice D? Yeah, it's going to be a double replacement again. Thank you very much. Double replacement reaction again. Double replacement reactions are not redox reactions. Why? Oxidation numbers do not change. Three best answers going to be choice A. We saw the change in oxidation numbers. Number 4, similar to last question. Question reads, which valence equation represents a redox reaction, oxidation reduction reaction? Please record your answer in the chat. Very similar to the last question. Yes, Irvin. Yes, Tintin. Thank you. Yes, Faith. Thank you. Thanks, Alex. Yep. That's Nadina. Again, if you're still stuck with that, I would encourage you to check out your notes. Topic 2, right there. Uncombined element on one side of the equation and is in a compound on the other side, the reaction must be a redox reaction. Choice C, element on one side in a compound on the other. Sulfur is on an element on one side, compound on the other. 6, the best answer is choice C. 4, the best answer is choice C. 4 is C. Next up, number 5, dealing with sodium. Sodium reacts with fluorine to form a form of a compound, NaF. Each sodium will do what? Please record your answer in the chat for sodium. Thanks, Zen. Thanks, Jumila. There's sodium for you. I zoomed on for you. Thanks, Nadia. Thanks, Alex. All right, so there's sodium. Hopefully, you guys at home have the same like handful of people expressing their answers. Hopefully, you guys at home know how to do these and stop being bashful. So here we go. We have Na. Okay. Na reacts with fluorine to form what? Na has a +1 when it bonds. What does that +1 mean? It means something to the valence electrons. It is not going to add an electron. It does the opposite of what it says. It's going to lose the electron when it bonds. It's going to take the electron, it's going to leave, it's going to lose that one valence electron. Why? Because it wants to get to a stable octet. It's going to lose the electrons. Metals with positive charges, they lose their valence electrons. All right, let me just draw this over here. Na has a charge of +1, but it has one valence electron. Let's check out F. Fluorine. Scroll on over. Checking out F. The most electronegative element in the periodic table, fluorine. Let's check out F. There it is. F has 7 valence electrons. It has a charge of -1. What does that -1 mean? Again, that -1 means you're not taking an electron away, but rather you're adding one more electron there. Why would you add one more? To make 7 + 1 into 8 to make a stable octet. You want to get to 8. So F, valence electrons, we have F with 7 original dots. And then you can now see the bonding interaction. You can see what's going to happen with the bonding. You can see Na is going to donate its electron. It's going to go from there to the F. It's going to transfer on over. Once it transfers on over, what happens? The electrons are gone. And you're going to have brackets here. Na's charge is now going to be +1. F's charge, it gained 1 electron. F's charge would be, whoops, -1. So that's where the negative comes from. It gains 1 electron. Each sodium will lose 1 electron. Best answer there, choice C. Loses 1 electron. Hopefully that helped you out. A lot of you guys that put the answer, put the right answer. Thank you. Number 5, the best answer was choice C. Number 6, in which substance is the oxidation number of nitrogen equal to 0? Do you know your rules? Please put the answer in the chat. Which one has an oxidation number equal to 0? Okay, a couple different answers that we have recorded. We have some B's and some C's coming in. But rule number 1 says every uncombined element has an oxidation number equal to 0, or atom's charge equals 0. If you look at the example, Na is by itself, its charge is equal to 0. Ca is bonded with itself. Cl is bonded with itself. That has an oxidation number of 0 as well. So if it's an atom or if it's bonded with itself, it has a charge equal to 0. Which one's bonded with itself or by itself? It's going to have to be choice B. Has a charge of 0. B is the best answer. How does it work for charges? The first one listed, the first element listed is a positive. The second element listed is a negative. So positive followed by a negative. Could be +1, +2, +3. It could be -1, -2, -3. Choice C, it's going to be a positive for N. O is going to be negative. Oh, -2. It's going to be -2. It's going to be negative something. And choice D is going to be, N is going to be positive. O is going to be negative. Again, 6, the best answer is choice B. 6 is B. Next up, number 7. I gave you some clues in the previous example. Which substance does sulfur have a negative oxidation number? Please record your answer in the chat. Yes, Irvin. Yes, Tintin. Yes, Faith. Yes, Nadina. Yes, Alex. Thank you. Thanks, Din. Sulfur has an oxidation number of a negative oxidation number. We know rule number 1, sulfur is an atom, it has oxidation number equal to 0. Can't be choice C. We should also know that the first element is positive. The second one is negative. Oh, sulfur is negative there. That looks like a solid choice. Choice D, we have first element's positive, followed by the second element, which is negative. No, sulfur is positive there. We're looking for a negative. And then choice B, you could have solved for. You could have said, hey, is sulfur a negative there? You could have done that. How do you do that? You take 1 calcium. The charge of calcium is +2, plus 1 sulfur. The charge of sulfur you're looking for, there's no rule for sulfur. We call it X, plus how many oxygens? 4. Charge of oxygen is -2. This whole thing has a sum equal to 0. You could solve for the expression, you'd realize that sulfur would be a positive. Calcium is positive, sulfur is positive, O is negative. 7, the best answer is choice A. Last question, here we go. Talking about a chemical reaction. The reaction between Pb plus Ag, 2 moles of Ag positive, yields Pb2 plus 2 moles of Ag. The Ag plus 2 is what? Number 8, please record your answer in the chat. We're analyzing Ag. All right, thank you. Please record your answer for number 8 in the chat. The reaction, we're checking out Ag. Ag goes from plus to an atom, which is going to be 0. Let's check out the oxidation numbers. Oxidation numbers change from plus 1 to 0. Can't be choice B because it goes from +2 to 0. No. It goes from +1 to 0. Can't be choice C because that goes from +0 to +1. No. So it's got to be either choice A or D. A or D. So now we have to take it one step further. We want to know, is it reduced or is it oxidized? Reduced or oxidized? Is it GR or is it LEO? Is it losing electrons or gaining electrons? That's the last step here. From +1 to 0. What's going on from +1 to 0? Think about that process. +1 to 0. It's getting smaller. The number is getting definitely smaller. The charge is getting smaller. Think about that for a second. Think about that charge. It's getting smaller. In terms of electrons, electrons are negative. How is it going to get smaller? Is it going to gain electrons or lose electrons? Think about. The oxidation number is getting smaller. Electrons are negative. If I take a negative charge electron, that's an electron, I grab it and put it on, I'm more negative. What I do, I took a negative charge, put it on. I gained an electron, I'm more negative. So that's gaining electrons, you become more negative. If you take an electron off and throw away, take a negative charge off your shoulder, get rid of the negative charge, you're losing electrons, that would be oxidized. This situation, a lot of you guys put the right answer. It's going to have to be choice A. From +1 to 0, that number is getting smaller. It's getting reduced. Reduction, reduced. That's where it's talking about reduced. Therefore, it's going to be choice A. All right, hopefully that helps. That concept's a little tricky to think about, gaining, losing electrons in that sense. Well, once you get that, you're in great shape for this unit. 8, the best answer is going to be choice A. All right, I know that took a few minutes. Definitely choice A for that when you could submit that if you want to. You don't have to. I'm not grading it, but that is the warm-up for today. Oh, we got 8 out of 8. Good job, guys. All right, let's move on forward. So that was mainly a review of topic 1, topic 2. Let's open up our guided notes. Let's continue on with class, figure out the half reactions for today. So please open up your guided notes. I'm not going to go through the entire unit like I did yesterday. By now, you should understand assigning oxidation numbers. You should understand redox reactions. And today we're going to wrap up half reactions. So we'll go through half reactions today. You can see there's only 2 more topics, but another thing you can see is we've been on this unit for almost a month. Yeah, we had spring break. We had all that stuff in there too. But we will be wrapping up this unit next couple weeks or next week. All right, half reaction, scroll on down, see where we left off yesterday's class. Hopefully you know the rules by now. And where do we leave off? We almost left off finishing up this reaction. So my page is page 6. Hopefully you're close to page 6. What did we do last time? We assigned the oxidation numbers for every element within this chemical reaction. Why? We wanted to figure out, is it a redox reaction or not? So a little heads up, what's going to happen next is don't draw these lines in there. What's going to happen next, we're going to analyze each element from the reactant to the product. So we're going to check out Cu from the reactant to the product. We'll check out Ag from the reactant to the product. We'll check out N from the reactant to the product. And we'll also check out O from the reactant to the product. But that's going to be called a partial half reaction, which we'll do right now. So let's analyze them. I think I'll leave those lines up there for now. All right, so right below that +5 for Z, I'm going to press enter 2 times, and I'm going to center this as well. And I'm going to leave my font just in black font for now. And the first thing I'm going to do, I'm going to analyze each element from the reactant to the product. So the first one is Cu. I'll blow this up a little bit bigger. Cu is the first element. And Cu goes from 0, I'm going to hit Control, period, 0, to Cu to the product side equals Cu plus 2. So the numbers go from 0 to +2. So there's definitely a change in oxidation numbers. We'll figure that out in a few minutes. Once you have that, let's analyze the next element. Press enter. Hit Control period again. Let's go through Ag. Ag goes to Ag. I'm going to hit Control period +1 to Ag. Follow that blue segments, blue bracket, Ag0. Ag +1 to Ag0. All right. Next, press enter. Let's analyze nitrogen. Nitrogen goes from N +5 to N. Follow the yellow bracket, N +5. So there's no change there. I'm not doing anything too crazy right now. And last but not least, let's analyze the last one, which is oxygen. O, and then control comma brings it on down. O3 goes to O minus 2. I know it takes some time to do this in the computer. 2, O, control comma, 3, control period, O minus 2. No change there. So all I did is I analyzed each element from the reactant to the product side. You could see if you didn't do the oxidation numbers correctly, assign them correctly, then your comparisons are not going to be right either. So let's go through it. Let's just check out the last two on the bottom. I'm going to highlight these last two on the bottom because these two did not change their oxidation numbers. I'm going to highlight them in red. And these guys would be like spectators at Faith's singing at the Stanley. So you have a musical at the Stanley, and you pay your ticket to go watch your musical at Stanley, or whatever, you're singing at the Stanley. These guys are spectators. You have a softball game, you have a baseball game. If there's fans there, they're just watching the game. Spectators at the Stanley, they're just watching the show. Whatever. These are spectator ions. So I'm going to color them red. I'm going to call these spectator ions. Spectator ions, their oxidation number. Oxidation numbers do not change. They're just watching the show, enjoying the nice show. I'm going to make my font a little bit smaller, just so I kind of have it all centered together. And then once I do that, I'm also going to copy my spectator ions. Oxidation numbers do not change. I'm going to paste it below for O2. Spectator ions, the oxidation numbers do not change. They're just going to hang out and watch this chemical reaction occur. Spectators at a game. They're not important. They're not going to lose electrons or they're not going to gain electrons. Which ones are important are the Cu and the Ag. So let's analyze those two. Now we got to think again. We got to think about electrons. We're analyzing Cu0 to Cu plus 2. Now trying to figure out, is it Leo or is it Gur? Is it losing electrons or gaining electrons? You're analyzing Cu0 to Cu plus 2. Think about that process. 0 to plus 2. Are you gaining or losing electrons? From 0 to plus 2. Anybody at home know? Thank you. From 0 to plus 2. So it goes from an atom to plus 2. How does it get to plus 2? You're going to have to take a negative charge, get rid of it. I'm more positive. I'm positive 1 now. Take another negative charge, throw it away. I'm now positive 2. So from 0 to positive 2, this is a process that's tough to interpret. It takes some time to get to. From 0 to plus 2, it's going to have to lose electrons. In this situation, maybe you want to think about the reference table for a second. Maybe you want to just look at, oh, Na, which I'm reanalyzing. We're analyzing, no, Cu. Let's analyze Cu for a second. Maybe you want to think about the reference table, Cu. What's that plus 1 mean? That plus 1 means you're losing 1 electron. What's this plus 2 mean? It means you're losing 2 electrons. Leo. It's got to be Leo. So I'm going to go to the right. I'm going to hit Control, period. Bring us back down. And this is going to be Leo. Loss of electrons. It's going to be oxidation. You have to identify which one's oxidation. You have to identify which one's going to be reduction. Next one, we go from +1 to 0. What's happening with the oxidation numbers? It's getting smaller. +1 to 0, it's definitely getting smaller. The oxidation numbers are being reduced. You see that. It goes from +1 to 0. Oxidation numbers are being reduced. This is going to have to be GER. If you identify Leo, the opposite one's going to have to be GER. Figure out which one's oxidized, figure out which one's going to be reduced. You can't have one without the other. And I'm going to color code these again just so I could copy and paste them in a second. I'm going to color code these. I'll make one of them blue font. I'll make the other one purple font. Because now we're going to do the half reactions. We're close. Seems like a lot of steps we're doing here. We are. I'm going to sneak this on the same page, so I'm going to make my font above for my example a little smaller. What I'm going to do next, I'm going to ask that you copy and paste the purple and the blue font. I'm going to copy it. I'm going to paste it right below, just so I could do the partial half reaction. Oof. All right, I'm on a new page. No big deal. All right, so I'm going to press enter, and now we're going to represent a partial half reaction. So this is actually the partial half reaction. These are going to be the half reactions below. We know Leo is loss of electrons, oxidation. The first one's going to be oxidation, half reaction. The first one's oxidation, half reaction. The second one's going to be reduction, half reaction. The last thing you have to do for this oxidation, reduction, half reaction is to balance them with the electrons. An oxidation and reduction half reaction must obey the law of conservation of mass, energy, and charge. So we have to figure out how many electrons were either lost or gained and to represent them in the right spots. Let's go back to yesterday's class. I'm looking for oxidation half reactions. Oxidation half reaction, scrolling up, there it is. Oxidation half reactions, you're losing one or more electrons, the oxidation number is going to increase. Oxidation number increases. Electrons are represented on the product side. You can see that. There's my electrons. Product side. There's my electrons. The product side. All right, let's scroll down again. Oxidation half reactions, my electrons must be represented on the product side. So I have to add electrons, E minus. But the last thing is I have to represent the correct number of electrons as well. How many electrons do I need? Or how many electrons did I lose from 0 to +2? How many electrons were lost? That's +1. That's +2. So 2 electrons were lost in that situation. So this would be a correct half reaction for oxidation. My electrons are on the product side. It's balanced. The oxidation number goes from 0 to +2. That's showing that you're losing electrons. Oxidation half reaction. That's correct. Let's look at the reduction half reaction. Reduction half reaction. It says reduction. Gaining one or more electrons, the oxidation number is reduced or decreased. electrons are on the reactant side. So you're trying to balance this reaction. My electrons must be on the reactant side. They're on the reactant side too. So let's scroll down. Let's balance this equation. Reduction half reaction. My electrons are on the reactant side. Reduction, reactant. My electrons must be on the reactant side. You can represent it before Ag plus 1 or after. I'll do it after just so my font stays the same color. Plus an electron. How many electrons were gained? Just one. To balance that thing out, how many electrons were gained? You should be able to look at that and say, oh, there's one electron gained. It has to obey the law of conservation, mass, energy, and charge. So yeah, one electron was gained from plus 1 to 0. If it said plus 2 to 0, this would be 2. If it said plus 3 to 0, that would be 3. And vice versa. 0 to plus 3, 3 electrons were lost. That is oxidation and reduction half reactions. That is it for the notes on this topic. I'm going to ask that you probably open up your notes, have your notes, and please open up your examples on topic number 3 for oxidation, reduction, half reactions. Let's go through and figure out how to do these questions. Before I do that, let's play a quick little flick. Half reactions. Maybe this will help you, maybe not. Here you go, 4-minute video, half reactions.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
We will learn our equations for simple redox reactions. A half equation shows what happens at one of the electrodes during electrolysis. So we do need to be able to complete and balance half equations for these reactions. Remember that oxidation occurs at the anode and reduction occurs at the cathode. Let's have a look at a simple redox reaction. A strip of copper wire is placed in silver nitrate solution. Over time, the solution changes color from colorless to bright blue. You will also observe silver metal crystal deposits on what was once copper wire. Why is the solution turned blue? Pause and think. This is a single displacement reaction. Copper metal, which is higher on the reactivity series, has displaced silver in silver nitrate. The solution has turned blue because of the copper-2 ions in the solution. This is also a redox reaction where a reduction and an oxidation are occurring simultaneously, hence the term redox. Remember that oxidation means the loss of electron and reduction means the gain of electrons. So for a redox reaction, electron transfer has to happen with one substance losing electron and another substance gaining electron. The silver nitrate is an ionic solution containing Ag positive and NO3 negative ions. So here is the equation again, with all the ions shown separated. The copper metal has been oxidized because it has lost 2 electrons to form Cu2 positive ions. If we take out this half reaction, we now have a half equation, whereas the silver ions have gained electrons to become reduced, represented by this half equation. They are called half equations because each equation represents half a redox reaction, either the reduction reaction or the oxidation reaction. When the two equations are added together to form the final redox reaction, you can see that everything, including the number of electrons, are balanced. To reform the ionic equation, The electrons are equal on each side and can be removed. What about those nitron ions in the original equation? As the nitron ions appear on both sides of the equation, they are called spectator ions, as they have no effect on the overall reaction, much like spectators at a football match have no effect on the final result of the game. Here is another redox reaction where the iron 3 chloride oxidizes iodide ions to iodine a solid. See if you can write the two half equations. Pause the video and work out the answer. Did you get it right? The iron is reduced and so gains an electron. The iodide ions are oxidized and so lose the electrons to form iodine. So in summary, half reactions represent either an oxidation reaction or a reduction reaction of a redox reaction.
All right, so there's another example of a half reactions. Let's go through and analyze some on our own. So the rest of the class, we're going to analyze some examples on half reactions. So maybe you want your notes. Maybe you want to try it out without your notes. So please open up your examples. Unit 8, topic number 3, half reactions. Okay, it's not a bad idea to grab some scrap paper as we do this. Let's try it out. So the first few I definitely will do with you, then I'll kind of let you guys try some on your own. Maybe on your notes. The example I gave you in class, the last example we did in our notes, this would be like the most extensive type of example, the toughest example you'd have to do. They're probably not going to give you a chemical reaction, have you identify all the oxidation numbers, figure out all this stuff. A lot of times they're going to give you those oxidation numbers already. Why did I make it more difficult? So you could see that you can solve the oxidation numbers, you can analyze them, you could figure out which one's Leah, which one's Gur, and then you can do all that as well. It does really build on top of each other. All right, question number 1 says, given the reaction Mg plus Cl2 yields MgCl2 solid, which half reaction correctly represents reduction that occurs? So it's telling you a couple things in this question. It's telling you reduction half reaction. It wants reduction half reaction. First thing I would do in this situation, I would look at reduction half reaction. Over to the left, my notes. There we go. Reduction half reactions. It's a gaining of one or more electrons, and the oxidation number is reduced or decreased. Another thing to note is the placement of my electrons. Electrons are on the reactant side. Electrons on the reactant side. The first thing I do is I go through it. I look at the placement of the electrons. If it's not on the reactant side, it's not going to be reduction half reaction. So reduction, electrons on the reactant side. There's my electrons on the reactant side, electrons on the reactant side. Okay, it could be A, it could be B. Choice C, my electrons are on the product side. Choice D, electrons are on the product side. So kind of like oxidation half reactions. It cannot be C, it cannot be D, because the electrons are not in the right spots. Electrons have to be on the reactant side. Choice A and B look okay. Next, I want to figure out reduction. I think about reduction, I think of Gur. Gaining of electrons is reduction. Which one of these is gaining electrons? Think about that process. You're going through the oxidation numbers, you realize Mg has an oxidation number of 0 to +2. Cl has an oxidation number of 0 to -1. Think about this process again. Think about the oxidation numbers. Here we go. Mg goes from 0 to +2. 0 to +2. How do you go from 0 to +2? It's getting more positive. 0 to +2 is getting bigger. If I were to gain electrons, which are electrons are negative. If I gain an electron, I would be more negative. If I gain electrons, I'd be more negative. That's not happening there. That's not the situation. No. From 0 to +2, it's getting bigger, the oxidation number. Therefore, you'd have to lose electrons. This would be a situation of losing electrons in terms of oxidation numbers. Another thing to note here, it says oxidation numbers is reduced for reduction. Reduced, reduction. Reduction, reduced an oxidation number. Choice B goes from 0 to -1. What happens to the oxidation number? It gets smaller. It's reduced. That's going from 0 to -1. It's going to be a gain of electrons, reduction. Number 1, by looking at the electrons on the reactant, looking at the oxidation numbers, number 1, the best answer is going to be choice B. We'll analyze more examples. It's going to take a few questions for practice. We'll figure it out. 1, the best answer is choice B. Let's take a look at question number 2. Question number 2 is asking which half reaction represents reduction. So again, we are focusing on reduction again. So I pull up my notes, analyzing reduction. There's reduction. Let's check it out again. Reduction, GR. Reduction half reaction shows gaining of 1 or more electrons while its oxidation number is reduced or decreased. Electrons are represented on the reactant side. The first step I would do is analyze the chemical equation, figure out where the electrons are. Reduction, half reaction. Reduction, half reaction, my electrons must be on the reactant side. Match up the hours. Reduction, reactant, that's where my electrons are. We know chemical reaction, this is my reactant, yields the product. Reduction, half reaction, my electrons have to be on the reactant side. So here we go. Check out, figure out, make sure electrons are on the left side. Choice A, electrons are on the product. No. Choice B, electrons are on the product. No. Choice C, electrons are on the reactant side. Maybe. Choice D, electrons are on the reactant side again. Maybe. So just by that, we have a 50-50 shot of getting this right. Know the placement of electrons, you have a good chance of getting this right. You're in the right direction. Now let's analyze oxidation numbers. Checking out oxidation numbers. S on atom, oxidation number equal to 0. Rule number 1. You have to know the rules. S on atom, oxidation number equals 0. Let's analyze choice C. It goes from 0 to +2. Analyze that. 0 to +2, is it Leo or GR? Is it losing electrons or gaining electrons? We think +0 to +2. Is it taking a negative charge off or is it gaining a negative charge? Choice C, Leo or GR? Once you get this concept, you're good to go. So I'm asking you guys in class, is it Leo or GR for 0 to +2? 0 charge to +2, is it Leo or GR? Thanks, Alex. One out of 25. Perfect. One person knows what they're doing. 0 to +2. Think about it again. 0 to +2. What's that +2 mean? I'd say, hey, check out the reference table. Think about this process because I know you know I know you know what this means. The plus 2 of Ca means it's not adding 2 electrons, but it's losing 2 electrons. Those 2 electrons that are there would now leave to make a stable octet. So yeah, it's definitely going to be Leo in that situation. So choice C, 0 to plus 2, is going to be Leo. Hey, we're not looking for Leo. We're looking for reduction. It's not choice C. Choice D goes from plus 4 to plus 2. So check out plus 4 to the oxidation number of plus 2. Check out those values. What's going on there? The oxidation numbers from plus 4 to plus 2 are getting smaller. Oxidation numbers is reduced or decreased. Those numbers are getting more negative. So plus 4 to plus 2, these oxidation numbers are decreasing. How does it decrease? By gaining a negative charge. Take a negative charge. Take 2 negative charges in, it's going to get smaller. So this is going to be GER. So it's a lot of steps for solving this expression. Choice D is the best answer for number 2. Any questions on how we did that? Any questions at home how we did that? I know a few of you guys know what you're doing. I can't tell by the rest of you guys. Please ask if you need help. Number 2, the best answer is going to be choice D. Let's try one more question. Last question. Which occurs in a half reaction? Na yields Na plus plus an electron. Na is going to be 0. It goes from 0 to plus. 0 to plus. Think about that process. 0 to plus 1. Oxidation number gets bigger. Oxidation number increases. Look at your notes. Oxidation number increases. It's going to have to be oxidation. So it's oxidized. It's not A. It's not C. Which one loses? Leo. Which one loses electrons? Na plus. That plus means it lost the electrons. Number 3, the best answer is D. All right, guys, it's almost time for quitting time. So I'm going to stop class here today. We'll go through the rest of these questions next time. I'll also give you time for the exit pass. Have a great day. Make good decisions. We'll see you later. Stay safe, guys. Have a good day. If you have questions, hang out. I'm here for you. Bye. We'll see you later, guys. Sorry I pressed you the bell. We'll see you later. Oh, it is? Cool. All right, have a good day, guys. Bye, Kim. Have a good one. Bye, Nadina. Bye, John. Have a good day. See you, Wendy. Bye, Kai. Have a good day. Bye-bye.